Hello everyone, so today we are going to learn how to interface rotary encoder with Arduino. A rotary encoder is a type of position sensor which is used for determining the angular position of rotating shaft. It generates an electrical signal, either analog or digital, according to the rotational movement. There are different types of rotary encoder according to output signal and sensing technology. They can be either incremental or absolute based on the output signal. The encoder that we are using is called Raster encoder, which is also known as relative rotary encoder. It produces a square output signal. Depending on sensing technology, rotary encoders can either be magnetic, optical, or laser encoders. Now let's move further to the working principle of rotary sensor. Here's how the square wave pulses are generated. The encoder has disk with evenly spaced contact zone, as you can see here. These are the evenly spaced contact zone, and there are two output pins, output pin A and B. When the disk moves, these spaced contact zones make contact with output pin A and output pin B and thus generates the square wave. Any of, any of these two outputs can be used for determining the rotated position by just counting the pulses. However, if we want to determine the rotation direction, we need to consider both waves at the same time. We can notice that if these two output signals are displaced at 90 degree out of phase from each other, as you can see here, 90 degree out of phase. If the encoder is rotating clockwise, the output A will be ahead of output B. This output A will be ahead of output B. So if we count the step each time the signal changes from high to low or from low to high, we can notice that the two output signal have opposite values. As you can see here it has 0 and 1 while moving in clockwise direction. But while moving in counterclockwise direction, this when we move from high to low or low to high, we have same values. So this is the logic from which we can determine whether the encoder is moving in clockwise direction or counterclockwise direction. Now let's move to the pinout. This encoder has 5 pins: clock, DT, SW plus and GND. Clock is used as pin A, as I have explained before, and DT is used as pin B. SW is a switch pin and plus is used as 5-volt DC supply. GND is a ground pin. This is the diagram that you can refer to interface this rotary encoder with the Arduino board. Now let's move to the code. Here we are using two states, a last state and a current state. If both states are not equal, then we are using this logic that I have explained before. I have declared here output A for pin number 2 and output B for the pin number 3, and this is the code that we have done on the basis of the logics explained further. And I have increasing the counter if we are moving in same direction, and decreasing the counter if we are moving in the different direction as of the current. The position that we are getting is displayed on the serial monitor. What is the application of this? Rotary encoder basically is rotary encoder that you can see here is used for regulating the speed of DC motor. It can also be used in the devices that are based on position sensing, or which are based uh, for adjusting the frequency, etc. This is the reference site that I have referred for this video. So this is all about the theory. Now let's move to the demonstration.
So I have done the pin configuration as explained before. These are ground and VCC pins which are connected to respective pins of Arduino, and then this pin of this CLK pin is connected to pin number 3, and then a DT pin is connected to pin number 2, and SW pin is connected to pin number 4. I have uploaded the code. This is the code that I have uploaded. I have explained it before, and now let's see its output on serial monitor. Initially it will have a blank screen. As I rotate this in clockwise direction, its position will be given, as you can see here, 1 2 3 4 5 6. And as I rotate it in anti-clockwise direction, the count will be lessen, and as I have rotated it to further anti-clockwise direction to its initial position, it is giving negative positions. So this is what the demonstration of a rotary encoder. So this is all. The references for this video are given in the video.